Okay, events are subsets of the outcome space. Therefore, we can take unions and intersections like we can for any sets. Let's think about the probabilistic interpretation of these things. So let A and B be events. We're going to define A union B to be the notion that at least one of A and B happens. So we're thinking of an inclusive OR there, as usual. The set A intersect B means both A and B happen. A complement means A does not happen. And whenever A is a subset of B, that means if A happens, then B happens. Okay, now let's state and prove a theorem. It has 5 parts. Let omega be a probability space, and E and F and A and B are all going to be events. We have 5 facts that follow out of this. The probability of any event is non-negative. The probability of omega must be 1. If E is a subset of F, then the probability of E is less than or equal to the probability of F. If A and B are disjoint, then the probability of the union is the sum of the probabilities. And finally, the probability of A complement is 1 minus the probability of A. Now let's prove all of these to some music. We can generalize the summation formula in the previous theorem by the following. Let's assume that we have n pairwise disjoint events, then the probability of the union is the sum of the probabilities. To prove this is relatively straightforward. For the case n equals 2, we've already done this in the last theorem, and in general, we just use induction. Here we're going to prove a theorem that says that if we have n pairwise disjoint sets whose union equals the whole sample space, then for any event E, the probability of E can be written as the sum I equals 1 to n of the probability E intersect AI. The main idea of the proof is to show that the sets E intersect AI themselves form a partition of E, and then everything follows. One direct corollary of the previous theorem goes like this. If we take any 2 events A and B, then the probability A intersect B plus the probability of A intersect B complement equals the probability of A. We also can show the theorem that says if we take any 2 events A and B, the probability of A union B is the probability of A plus the probability of B minus the probability of A intersect B. And we can prove this using a Venn diagram.